earlier, but a couple more people came in. PHP developers, show of hands. Thank the good Lord in heaven. Okay, I realized I submitted this talk to Ski PHP, which got absorbed by Openwest, so I realized after the fact that I don't think the talk description actually says anything about PHP. So this is mostly testing in PHP, testing spaghetti in PHP legacy code. If you were expecting something else, you can leave and I'll be sad, but I won't, come after you or anything, so that's fine. I'm Gemma. I'm not like a tech luminary or anything. I just do stuff in tech sometimes. I got started, this is my claim to fame, I got started at the Center for Radiophysics and Space Research at Cornell University because my dad worked there. Nepotism alive and well. I spent 6-ish years doing C, like ANSI C89C in the postal mailing industry. These days I work for Proxy, which is a global network of proxy and VPN servers. They're pretty cool. I'm not super interesting, so we're going to talk about pasta. If you're here, you probably have worked on a PHP legacy application, and it looks like this. Yes. It's not fun. I mean, it can be fun, but when you first open up the file and you look at it, you're like, oh, again. But what are we talking about when we say spaghetti code? What does that mean? This is the sorry. Yeah, thank you. So this is a quote from 1974. This is one of the earliest references I could find to spaghetti code. Denny Van Tassel. I don't know if you can you read the bottom of the screen? It's probably too low. Okay. Denny Van Tassel is a CS educator, computer science educator. And this quote is from a book called, I wrote it down, Program Style, Design, Efficiency, Debugging, and Testing in 1974. Like, how cool is that? So large monolithic programs are like a plate of spaghetti. Pull it here and something moves on the other side. I like this quote because that's not what I think of when I think of spaghetti code. This seems like more an indictment of non-functional languages with side effects. So like you change something here and all this other things over here changes. So I thought that was interesting because it's not exactly my definition. This is closer to my definition. So this is 4 years later. Code having the same clean logical structure as a plate of spaghetti. So this is more about internal structure, less about external effect, which is more where my brain is when I say spaghetti code. And this is just a quote I liked from a blog I randomly found. It's incomprehensible unless you have the discipline to follow each noodle through from one side to the other. So this is even another aspect, moving from internal structure over to comprehensibility, readability. In 1974, this is what they were talking about when they said spaghetti code. You'll notice go-to there. This is in none of your code bases, right? 0. Okay. So labels and go-tos and just an absolute, this is like obviously a very small toy sample, but this got really bad. And this is what people were talking about when they said spaghetti code in 1974. So after, defining spaghetti code, I went to Wikipedia, and turns out there is an entire taxonomy of programming pasta. What I think of as spaghetti code in the PHP ecosystem, Wikipedia says is actually macaroni code. So everything is all mixed together like macaroni and cheese. Or as I call it, SQL and all the things. Who's seen code like this? Yeah, most of us have. So we start with the classic XHTML 1.0 transitional. Yes? All right. And then we move into rendering our page, which is fine. And then I got to go get my title of the page from the database. So let me just do a quick MySQL query with MySQL_query, everybody's favorite. Set a default if we can't find it, and then just keep rendering the page. Macaroni code, everything mixed together. More of the same here. So we're rendering now, we're in the body, and I need the posts for my blog. So I'll just go get them with MySQL query, and then I'll display them in line, just looping over the raw result. Macaroni. Who has common.php in their projects? Yes, yes, I do. I have not seen a project that was built, that was started like more than a couple years ago without this. This is the common dumping ground for just everything where you don't know where it fits in a class, you don't know how to put it into a class, you're in a hurry, you just got to get it out. So it has things like this. Get user by ID. Get user by name and password. You might these might be like right after each other. Common functionality tends to be grouped because whoever was putting common.php together in the first place was like, well, I'll just keep them together so it's comprehensible. That's not so bad if they're near each other in the file. No shared code here, none. No testability. And it lends itself to copy-paste errors. If you look at the second example there, well, that's wrong. We're looking for a name, not an ID, in the MySQL query. So this was clearly copied directly from getUserById into getUserByName and password. They added the password and went running with it. This could be later on in the file. Maybe this is at the bottom. Maybe this is 2 years later, and they've got a new developer, and the developer doesn't know common.php, so they just kind of add stuff to the bottom of the file, and that's fine. And more of the same here. In this case, we've got business logic up at the beginning. So we've got some, is our password long enough? Does the name exist? Does the password exist? We've got some like guard checking up here, and then we just go straight into the database. All in the same function. This is also not testable. And mixing your business logic with your database logic means your business logic isn't testable unless you can get to the database. So this is a problem. If you're using a framework, you might be thinking, oh, it's OK, I've got a controller. My controller is handling all this. I don't have spaghetti code. It's fine. So this is a micro framework. It'll look familiar if you've done anything with Silex or Slim. It's called Bullet. It's my personal favorite. And most of the code is in that middle section there, which is roughly equivalent to a controller. And this is the same thing. We've got more business logic mixed directly with our database logic. So this is still not testable. None of this is testable. It's also not reusable. Can you think of anywhere else you might want to use that business logic? Check to see if the pet's name is longer than 3 characters. Maybe if you're editing a pet later on. And you can't because it's all just sitting here. Not reusable, not testable, spaghetti. Do you really have to care about this? It's shipped. It's running. You're making money. Like, people are signing up for your thing. And they don't seem to mind that your code isn't testable. So why do we care about this? Repeatedly duplicated code lends itself to copy-paste errors, as we saw. It gets harder and harder as you're copying bigger and bigger chunks of code around to make sure you munge the new paste to fit the context that it's living in. So do it often enough, and you're going to end up with stuff like that. The ID equals ID when you're actually looking for a name. It's harder to understand. It's harder to read. It's harder for the new developer who just came onto the project to grok what's going on and really understand sort of the flow and how the logic is supposed to work. And it's harder for you in 6 months when you haven't looked at it in 6 months, and now you have to go back and change something, and you got this. It's a mess. It's a mess. You don't want to deal with it. It's a mess. It's ugly. And this is the other problem with copying and pasting big chunks of code. If there were bugs in the original that you didn't find yet, you've just pasted them into your new location. And you didn't know they were there, so maybe you copy-pasted this really convenient section 6 or 7 times in different places. Then you find the bug in one of those places, and are you going to remember like all the different places that you pasted it? I'm not. Personally, I'm not. It's not going to happen. And this is the big problem with spaghetti code. You can't test it. And if you're not on the testing bandwagon yet, this is where I attempt to get you on with science. We're going to use science. There's a reason that testability seems to become the goal in these kinds of conversations and talks. So not exactly our science, but other people's science. We're just going to read it. So this is empirical. The name of this paper was Empirical Studies on Quality in Agile Practices. This was a survey of studies of Agile practices. So a lot of individual studies on like just TDD or just Scrum or just XP or something like that. They did a huge survey of all of them. 15 of them, which is basically all of them that touched testing, showed extensive quality improvements directly resulting from TDD specifically. If you're not on the TDD bandwagon, that's fine. I'm not really that much either. But just adding TDD to these projects improved the quality of the code. This is the classic. If you look at software engineering research and you're looking at Agile practices and testing specifically, you're going to run across this study. It was a really big deal. These were actual projects at IBM and Microsoft. They weren't just toys. They were real engineers doing real work. They added TDD, 40% defect reduction at IBM, 60 to 90% at Microsoft. 60 to 90% defect reduction, like just that by itself is a reason to start testing your code. This is another one. This is unit test automation now, not specifically TDD, just automated unit tests. 21% defect reduction after introducing automated testing at Microsoft. And this is the one that you go to your boss with. Defects found at the unit test level are cheaper to fix, but like exponentially cheaper to fix. So if you have the option to do that, do it. And the bottom line, if you can't test your code, you are missing out. So is your company, so is your team, so are your users. So having testability as a goal is a good thing. It's not just a distraction. It's not just annoying. It's a little annoying, but it's not just annoying. It's worth doing. So we know what we're talking about when we say spaghetti code or macaroni code, whatever. We know it's bad. Let's start fixing it. So to do stuff, we need tools, right? So I'm just going to very quickly, hopefully, gloss over some tools you may want to use. You're probably already using some of these. Composer. Who's using Composer in their projects? Yeah, good. That's almost half the room. Okay. It's not actually a package manager. It's a dependency manager, but it acts like a package manager. It's close enough. It has no dependencies, which is lovely because your IT guy or DevOps people can't yell at you for using it because everything you need is already there, PHP. I think the oldest version of PHP it supports is like 5.3, I think, 5.3. Maybe 5.2, I think it's 5.3. So if you're on 5.3 and up, and hopefully you are, if you're on 5.2, you have my condolences. Hopefully you're on 5.3 and up and you can use Composer. In addition to having no dependencies, there are no side effects of Composer outside your project. It doesn't touch anything else. It only messes with your project. It installs its dependencies into your project, by default, a vendor directory, and that's it. It's not opinionated, which your perspective on like opinionated tools may vary. In this case, I think it's great because it means you can add Composer to any project at any stage, no matter how gross it is, no matter how much legacy spaghetti nonsense there is. You can add Composer, and it won't touch anything until you ask it to touch things. I really can't emphasize enough how great it is to not have to fight with your sysadmin about getting your dependency manager. If you've had to, if you want to do builds with Grunt or something, and you've had to fight about getting NPM and Node on your development servers, which I have, it's not a fun conversation. So this is the officially sanctioned way to install Composer. You're piping it directly off the internet into PHP, which is bad for your health. What?
Generally horrible.
Yes, generally horrible. This is on their website. That's my excuse for putting it here. Also, it fits on the slide. Really, you should go look at it and confirm that it is what you think it is. It's not going to blow up your system. Download it to your computer and then pipe it to PHP. But that's how you get it on your system. And setting up your project with Composer is as simple as those next two lines. Init, install, done. That's it. Now you have Composer in your project. I should have had a slide on this, but I don't really. If you're using version control, which of course you are, right? Yes. Generally speaking, you're going to version control composer.json and composer.lock. You're not going to version control vendor. The .lock file, I think this is the same as NPM, or it's close at least. It defines what hashes and what versions of your dependencies that you need, and you'll just grab those later. So you don't need to throw a vendor in your version control system. I had a fight with somebody on my team about that once. It was fun. So I use Phpunit. There are lots of other valid options here. Anybody use codeception? Okay, Bhat? I don't know how to say it. Okay, Bhat?
Yeah.
Okay. Simple test. Who remembers simple test? Nobody? Oh, come on. Oh, it was like PHP 5.0. It was one of the first testing frameworks for PHP. Anyway, okay, these are all valid choices. The important part is that you have a framework that lets you get up and running testing very quickly. So yeah, installing Phpunit once you have Composer is as simple as that. That's all you need to do. And writing a Phpunit test case, this middle right here, okay. This is the whole file, just it's like what, 4 or 5 lines? So we're testing that math still works. We've created a test class called myTest. We've created a test method called test that math still works. And we've got our assert checking that 2 plus 2 is indeed equal to 4. So literally 5 lines and you're up and running with a Phpunit test. And then actually running the tests is just grabbing the Phpunit, not binary file, executable from your vendor directory where Composer puts it for you automatically, running that against your test folder, and you're done. So it's very nice and speedy. It doesn't take a ton of learning how to do all the things. It's pretty self-contained and fast. So those are the tools. It'll help to talk about some of the concepts at work when you're trying to refactor legacy code into something testable. Single responsibility principle, who already knows what this is? Okay, a couple people, sweet. So have you heard of SOLID, S-O-L-I-D? Anybody? Okay, so these are the 5 principles of object-oriented design. Single responsibility principle is the S. It's the first one. I'm not going to talk about the rest of the 4. And I had a guy once who got mad at me for not talking about the rest of the 4, so I'm really sorry. I don't have time. Single responsibility principle. Or do one unique thing. Your methods and classes and your code in general should do one unique thing, do it well, and do that, and nobody else should do that. And it's important for several reasons, one of which is maintainability. If you have a concept, and you wrap that concept entirely in one piece of code, in one coding context, and anytime you want to do anything with that concept, you use that code. When the concept changes, all you have to change is the code that you've wrapped it with. And that's it. You don't have to, grep through your source code for 3 hours looking for every single time that you touch this database or table or whatever. It's all in this one piece of code. And that makes maintainability a lot easier to deal with. Also testability. For roughly the same reason, if you've got this concept wrapped in one piece of code, you can just test that one piece of code. If you've got the concept spread over zillions of files and zillions of functions and everywhere, and it's a mess, to test that concept, you have to test all of that extra code. And it's annoying and impossible in some cases. It's not great. So if you're going for maintainability and testability, the single responsibility principle is your friend. Do one unique thing with your code. Spaghetti code is responsible for very many things. So let's list some of the things, shall we? We've got structure, HTML structure and rendering. We've got some database access, obviously. We've got some business logic. So if there's no posts, we're putting out this paragraph of whoops, no posts, and otherwise we're looping through everything. And then we're doing more HTML, more rendering, more view. And then we're closing off our closing off the render at the bottom. So there's a lot. This code is doing a lot. This is macaroni. Lots of stuff going on in this one piece of code. It's overachieving. It's trying too hard. Your code should be lazy. And you can do that with dependency injection. Who's familiar with dependency injection? A couple people. Sweet. Yes. Awesome. All right. What's a dependency? Here's an example. So this is just a random common.php function. We're grabbing a template file. And to do that, we have to go get our config object, because that has our template directory in it. So we got to go get our config object, we got to get the template directory, and then we can find our template file for this. Grabbing the config object is a dependency. That's this. If you want to test this function, this get template file function, what does config need? Like, does it touch a database? What do I have to wire up to get a test for get template file to work? That's a dependency. Dependency injection is how you get to lazy code. So if you have too much responsibility in your code, remove some. So instead of having get template file be responsible for creating a config object, just pass it in. There's a technical name for this. It's method injection or something along those lines. Sorry? Dependency inversion. I'm talking about injection. Inversion injection, two different things. I'm not really going to go into inversion. But this is, so we're just injecting our config object into this method. If you're really big into OOP, you're looking at this and going, actually, you should just be injecting the directory. Yeah, but we're going baby steps here. This is better. This is better than it was. And this is testable, because we have now injected a dependency into this code. So when your code is only doing one thing, and all its dependencies are injected, which it is in this case, we're building a template file name, and the config object is injected. You can inject a fake dependency, which lets you test it. So in this case, we've got a template test class in Phpunit. We're testing our get the template file method. And instead of passing in an actual config object, we're passing in a fake one. Really, because I have no type hinting anywhere, I could have just passed in just like a regular standard class without even using getMock, and everything would have been fine. But just getMock is part of the Phpunit testing suite. It's super handy in some cases. We're going to use it later. So this is getMock. So in this test, we're creating a fake config object. We're slapping a template directory on it, and we're passing that into our new template. Which means we can control the template directory. So we've set it to foo here, which means that we know what should be coming out. So we can write the test to check that our result is, in fact, foo/bar.html.php. Any questions so far in any of this? OK, cool. So those are some foundational concepts. Single responsibility principle, dependency injection. When you're actually getting down into it, getting down and dirty with refactoring your code, there's some principles to keep in mind. First of which is don't try to do it all at once. If you are like me, you looked at this code and said, I need a user object. This should be a user object. There should probably be like a separate model. Maybe user service, repositories, entities, all of it. I need all of it right now. Take a deep breath. You're right. You're absolutely right, but you don't have to do it all at once. If your goal is testable code, you can work in smaller increments, and it'll be OK. So let's start small. We'll start by refactoring get user by ID, and we'll create a user object here. We've got a very simple constructor. We're passing in our database object. In this case, I'm using MySQLi because it's convenient. Other options include PBO or like Doctrine, or go nuts with your ORM goodness. MySQLi is simple, so that's why it's here. The static function by ID is like a static factory method if you're into design patterns. That's going to load our user from the database. And the important thing here is we are injecting the database service. We're not just calling MySQLi underscore whatever directly in the routine, in the method. And we're doing lots of error checking. So we do our prepare. Who's familiar with MySQLi? Have you guys used this? Bunch of people. OK. So prepare is how you do. It's the alternative for like raw SQL statements. So if you're used to using MySQL underscore query, you would use prepare instead. Prepare gives you a statement, and then you can do all kinds of error checking on that statement. So we're checking to make sure the statement is a non-false value. Then we're checking our bind parameter. We're doing prepared statements here, so we're binding the ID to the integer. Sorry, bind param I means an integer. We're looking for an integer. So we're binding the ID variable that we passed into the method to our where query, where ID equals question mark. We're doing the statement execute. We're getting the result. We're getting an associative array of everything. And we've got error checking on all of this. Normally, I'm like shaking the. Normally, I would have all of these if conditions on separate lines to make it readable, but I ran out of space, so it's all kind of squished. My apologies. But the beautiful thing is that since we're doing all this error checking, we have all this testing we can do now, which is great. Since we passed in we passed in our database, we passed in our MySQLi database object that we're going to use to talk to the database everywhere. Since we passed it in, we injected it. Now we can inject a fake, and we can say, okay, so I'm going to create this fake standard class database object. Get mock lets you specify methods that you want to exist and not do anything. So in this case, we're saying, create me a standard class object and put a prepare method on it that doesn't do anything. So we create our mock as our fake database, and then we define the expectation for that prepare method. So in this case, you can read it like English. It's like the database object expects one call of the method prepare to return false. So you're saying that, all right, this prepare method that we've now slapped onto this object, when it gets called, it's going to return a false. And then we assert that the result of grabbing the user 123 with the byId method is null. And the reason we're doing that is because if prepare returns false right here, it gets thrown into the statement variable, and then the first thing the if statement checks is the statement. So if the statement is false, we're done, and we return null at the bottom. Does that make sense? Does that not make sense? OK. So right there, we've tested one of our error checking conditions in 3 lines of code. Now that we have our beautifully testable user class, we can plug it right back into getUserById, our original common.php function. So instead of having all of that logic and all that lack of error checking in this function itself, we just grab the user with our new class using our byId method, and we return the details if we find it and null if we don't. Because that was the interface for getUserById. GetUserById takes an ID, and it sends back either the associative array of the user details if it finds the user, or null if it didn't find the user. And that's exactly what we're doing here. Keeping the interface the same means that you can keep using getUserById. You don't have to go through your entire code base now and find all of the getUserById instances and change them, and then do all of the testing for all of the places where you changed it. You've kept the interface identical. So you can test the class and verify that that's working, that's fine. And then getUserById is just wrapping the class. So you don't have to do anything else. Now you're done. The class itself, like this, let me just read the slide to you. The class itself will be a foundation for future refactoring and development. So when you're doing more stuff with user, you want to change it later on, you want to add functionality, you can do that on the user class instead of just adding more stuff into the bottom of common.php. And yeah, keeping the interface the same on your original is key for this do one thing at a time. It speeds you up considerably. And you can, if it becomes a priority, you can go through your entire code base and make everything use the new user object. You don't have to keep using this. But this simplifies what you're doing. Don't quit your day job because you have stuff you actually want to do. You have managers and you have bosses and whatever, and they want you to actually add functionality and do extra things with the code. They don't want you to just sit there making it pretty all day, much as we'd like to do that. You can refactor and develop at the same time. And if you talk to like a really hardcore like Martin Fowler, super agile person, they're going to start twitching at this statement because you're not supposed to do this. You're not supposed to refactor and develop at the same time. You're supposed to just refactor and then develop. But working in the real world, if you can combine them, you'll save time, and that's a good thing. So if you work in small increments, and if you keep the interface the same, like we did with that get user by ID, you can pull this code out, make it testable, and add stuff to it at the same time. So here's this is our other common.php routine, our method. Get user by name and password with our bug still in it, which is great. Your manager wants you to make sure inactive users can't log in. So done. No problem, right? I mean, the bug is still there. But, we're checking for active users now, so it's fine. Or we could just see if we can add it to that user class. That's so nice and testable and new. The other problem, of course, with this is that we're still violating single responsibility principle. We're not injecting our dependencies. This is not testable. So let's see. Here we're back in our user class. We've added another factory method called by name. This is going to look a lot like by ID, except we're using the name. And if you notice, that means there's more refactoring capability there, or possibility there, because you're probably going to just copy paste the contents of by ID into this. And that's your key. That's your, I could be refactoring this into something more common and usable and testable. So our by name is going to be just like by ID, except with a name. And we're adding this new login function. Somebody gave a talk today about how exceptions are the devil or something, which is fine. I mean, that's a valid opinion. They're super convenient, so I use them for things like this. You could just as easily make this function return true or false and check the value. There are multiple ways to do this. I like exceptions, and using exceptions will let me show you more cool PHP unit things, so I'm using exceptions. So we've got our business logic here. So there's no database access. We've already pulled the user from the database. We're checking the values. So does the password match? If it doesn't, we throw an exception with a message. Is the user active? This is our new functionality. If it doesn't, then we throw an exception. Another thing to point out is obviously don't do password checking like this. Use the new beautiful password underscore stuff in PHP 5.5. If you're not on 5.5, use the password compat library for like 5.3 and 5.4. This is not a secure way to do this. It's just a toy example to illustrate a point. So here's what our test could look like for this. You'd have other tests for the by name routine that would look a lot like the test for the by ID. So the interesting tests here are for the login method, our new login method, where we're just doing business logic, no data access, just business logic. We create a new user with a password, and we check to see if it can log in with the wrong password. If this test gets all the way to the end without throwing an exception, PHP unit will yell at you, because you've annotated it at the beginning with, we're expecting an exception, and this is the message that we're looking for. Same routine with the checking for an inactive user. If the test method gets all the way to the end without throwing an exception, PHP unit would be like, wait a second, I was expecting an exception and I didn't get one. So yeah, this is how you can test the new business logic that's separated from the database logic, and how you can do exception testing. Any questions on this so far? Awesome. Okay. Integrating with Oh, you're fine. Integrating with the original get user by name and password method. So this is our common.php function that's just sort of global and sitting there. It'll look familiar. We're going to grab our user with the by name factory method. If we can't find it, we return null, which is what the original function returned. And then we're going to check and see if the user can log in. And if we get an exception out of the login method, we'll return null, because that's what the original function did if it couldn't find the user with that password and active status. And then if we're successful, if we get all the way to the bottom, we return the associative array of the user, because that's what the original function did. So again, we have not changed the interface on this function. You don't have to go through your entire code base looking for get user by name and password and changing everything. We've in place made this more testable. You are now a multitasker. You've refactored old code while simultaneously adding new code. Any questions? Okay, sweet. So the third guiding principle is be sneaky. A lot of times, you're going to look at stuff like this, and you're going to say, I need an MVC framework. Get me Zend framework right now. Get me Slim. Get me Symfony. Get me something. I need a framework. This is what I need. Because this is, you know, page logic and database logic. It's all in the same thing, and I'm obviously displaying a web page, so give me a web framework. That's what I need right now. You can do that, and you can rewrite your entire application with a framework, and that's fine. And if you have time to do that, do it. Absolutely. If you can sell your boss on that, do that. By all means. If you can't, you don't have to. You can kind of get in under the wire with this. So this is a very naive example of how you might represent the page that you're rendering as an object. It's going to look familiar. We've got our static factory method that pulls the data from the database. We've got our constructor that's very light and doesn't really do anything. And then we've got this title method here, which is checking to see if the title exists, checking to see if the title is non-false. So if it's like I think if it's like a 0, it's like a string that's a 0, you're going to have a problem, but you probably don't want that as your title for a page anyway. There's more extensive checking you can do on this. This is just good for an example. So we're checking to see the title exists, that it's populated, and if it is, then we send it back. And that's going to be our title. If it's not, we have this default defined in the code. Sorry? What did I do? Oh, yes, you're absolutely right. Yep, yeah, that whole routine should have this details. Sorry, thank you, I'll fix that. Because that's a property of the class. So we could set up tests for this now. Check to see if we get the defaults, if the title is missing or if it's not, or if it's empty. And check to see that if it is set, then the right thing gets returned back out of this function. So you've now made the original, like, pull stuff out of the database and do some business logic testable. Now testable. And you can just slap it right into the page. You don't need a framework. You can do a framework, and frameworks are wonderful, but you don't need one. You can just grab the page at the top of your HTML file. I mean, it's better than what was there, right? And slap the title right into where you had it before. So again, we're working with what's there. We're pulling essential business logic out and making it testable, but we're not completely rewriting the entire application. Prevention is the best medicine, and it is hard. It's very hard. How did we get to this situation in the first place? It's faster. It's always faster initially. It is always faster to monkey patch. It's faster to just add that active equals 1. I mean, you saw it right there. That was like 10 characters, not even 8. It is faster to do things the ugly spaghetti way at the beginning, every time. it's easier. It's much easier. It's much easier to look at the SQL query and be like, oh, I just need to add. So I'm already pulling out name and password, and I just need to add active onto that, and I'm fine. Like that's way easier than stepping back and saying, okay, what's the design? What's the structure? That kind of thinking is a different skill than script hackery, and it needs to be practiced just like any other skill. And make no mistake, I have no claims on having like high amounts of this skill or anything, but it is a different skill, and it's something you need to develop in addition to script hackery. Your users don't care. This is the other reason it happens. Your users don't care, which means your company doesn't care, your boss doesn't care. Nobody cares. If it's running, if it's making money, they don't care. And they don't want to give you extra time for this kind of nonsense. So how do you stop it? You have to care about your code. And you might not. You might be working in a job that you really don't like very much, and you don't like the company, and you don't care. You're just kind of, passing time until you can get a better job, and that's fine. But you might care. Like maybe you care about the job that you do. You want to do a good job. You want pretty code. This matters to you. You have to care. If you don't care about the quality of your code, this entire talk is pointless. And now that you care, you have to work. Caring is easy. Discipline is very, very hard. At least for me. Like I get very excited about code quality and like making sure that the styles are all right and everything, but working to make things better takes hard work. It takes hard work. Spend the extra hour to help the next guy who's going to run across this code and have to deal with it. And the next guy might be you. So, And it takes extra time. That's a common thread through all those studies that I listed out that I didn't mention on the slide because there wasn't a lot of room. Doing the upfront testing, doing the upfront design work takes longer initially, always. It's worth it for the reasons in those studies, but it takes time, and you're going to have to fight for it. Because your managers, your bosses, your companies they're not going to want to give it to you because you can get the code running without doing it. So fight for that. Fight for the quality in your code. It's okay to have spaghetti. It's okay to put in more spaghetti. Sometimes you can't help it. Sometimes you have to get a thing out the door in half an hour and you just don't have time. But you can refactor it and you can make it testable and you don't have to kill yourself to do that. And that's all I got. So thank you very much. It's been a great audience. Any questions? Yes.
What's a good way to test your database code because of errors and data units,
The actual SQL queries and stuff?
Yeah.
Phpunit, and this is true of a whole bunch of other testing frameworks as well. Phpunit has built-in stuff that'll let you specify your database schema ahead of time and put in dummy data, and then you can write tests against the dummy, which is really good and really important. I would recommend if you do that, make it something you can turn off that you have the option to turn off when you run the tests, because you may be running them at some point in an environment that doesn't have a database set up, and then it's just annoying. Then you got to go back through and comment everything. It's a pain in the neck. But yeah, you can do that with Phpunit. You can also do that with other testing frameworks. Any other questions? All right, cool. Thanks.